Hello everybody. It's clock sharp, so we can start. I'm happy to see a lot of names today. we have Netherlands, we have Belgium, we have Switzerland, Italy, Poland. That's great. Okay, I can switch my camera. Hi.
Hello.
Nice to see you. Nice afternoon to everybody, and I switch it off because it would be difficult for our lines. So we are here to show you something about new version of IDEA Connection. We planned the new release in the first week of June, and you can see we have first Friday in June, and I can say that the version is ready. So it's almost unbelievable, but we are on time.
Congratulations.
It's quite irregular. So I have prepared the document about moves in version 6. There is the brief overview of new things, and then a detailed document about all of this. So we can start with this brief overview. We made a lot of improvements in user interface. There is completely new graphical design. We have highlighting of items in 3D and tooltips. We linked our 3D scheme with property dialogues. You can click into screen and select operations. We add dimensions for each operation. We get units implemented, and some small improvements. We made quite simple but very important change in loading. Because during the version 5 we realized that a lot of users have troubles with the idea that forces have balance on the joint. So we introduced something like simplified mode, and in this simplified mode it is not necessary now to keep forces in equilibrium. There were a lot of requirements and proposals about output report. So we have now 3D drawings in output report. We add the tables with the general settings, tables about the base plates and foundation blocks. We also add one special chapter where is the description of the CVFM method. We changed quite a lot of words. Again, there were some. It was a little bit weak point in version 5. So we changed the editing of words. There is new edit tools. Tool for it. We introduced but words. and what you will see. And we add special new presentation of forces in welds, and we introduced also the new way of evaluating stresses in welds. For bolts, there are some smaller but important improvements, like that we can check bolts on full shear area, not only the area in the thread. The diameter is taken in a good model, and they are in bill of material. There are several new manufacturing operations. The main improvement is the general intersection of circular hollow sections, and everything with this require tubes. It means there are end plates, base plates, stiffeners. The support stubbs, also hips can be put on tubes. We improve connecting plates when they can be covered. We have generalized openings in the way that opening can now go out of the plate. It is only partially in the plate, and so we can model notches. Also, we can make roundings in the corners. Some improvements in gusset plates, plate editor was improved. In 5, if there were more plates in one operation, not all of them can be edited. Now they can be. Base plates, we improved a lot checks of concrete part, and also other things. Yes, again, circular base plate, we can do anchoring into vertical wall. From the point of view of cross sections, we connect IDEA CSS into IDEA Connection, so you can input general cross section composed from round sections from plates welded together. And we did a new implementation for analysis of stiffness. Okay, so we can go through this improvements a little bit more in detail. So we changed user interface. You see the new layout. Now it fits with our basic IDEA Statica application. It fits with our web and all materials which we have. So the drawing of 3D is now active. It means that if I go over the picture, the items from the joint are highlighted, and here in the bottom part of the screen you can see see description of what is there. So this can help. And also, if you click on it, if you click on plate, for instance, this one, you see that this operation is automatically selected in the list. Yeah. I click on this one, and here, so I can click and I can directly do the editing. So especially in more complex joints, it's much easier to find a specific thing, and you can directly edit in the dialog. Now we have this dimension line. I have selected this one, this rib or widener, and it has its own dimension lines. So you, when you input something, you directly see dimension lines. Now I select this one, and we have the dimension lines of this. Anyway, this project is from Emil Pertenborg from Netherlands. So it's not made by me, but it's done by Emil. Yeah, so for every operation we have this dimension lines. I can say that it is not yet in the analysis in the report, output report. This is the first step for making something like drawings or some more data which are necessary for description of the drawing. So this is the first step. We would like. Would be very happy if we discuss the possibilities of all this, and maybe you can come with the ideas how to make the drawings of corrections and put them in the analysis, in the output report. So this is a smaller improvement, but quite useful if you want to make welds between two plates. We have numbers of edges, and so you can define the edge which should be welded. 4 units. We have a new dialog. Setup, and there are list of quantities which we use in IDEA Statica. Not all of them are used in connection. Yeah, but for instance, here we use the length of cross section, so in millimeters. You can change it to inches, imperial unit. And you can set number of decimal digits in the dialogs and in the output. Another improvement was this local coordinate systems of members. This can written which then, so if you input your loads, it can help you in proper definition of internal forces. In loads, I told you that we make changes regarding this balancing of internal forces. We go to the load dialog. Now we have this new button, check equilibrium, and you see new object here, and I'm not sure if it is right shape of this, but it should tell you that the model is supported in this place. Yeah. So in this simplified mode, we have this bearing member, and the bearing member is supported on both ends. Yeah? And then if it is supported like that, it's not necessary to keep forces in equilibrium. You can put there what you want or structure. The table is simplified. There are only rows regarding these 4 connected members, and there is nothing about this equilibrium. You want to, of course, if you want to analyze only connection, then in fact you are not interested in the forces in this form. Yeah? But and then it is enough to support it like that. But for advanced analysis, you should you could change it. Then we have only one support. One is necessary, and for instance. For instance, here we can say there is internal force, normal force, yeah? And of course this force has influence to the stresses in the column, and it can influence also the connection. And, so for advanced users, everything is the same as it was before, so you can input internal forces everywhere. You can have information about the balancing, and you should keep the joint balanced. But for beginners or not so advanced users, it's here a new simplified method. And this is very similar what they do in standard component method program. This method, in fact, you can say you can solve only connection. In our software, we can resolve the whole joint. This is the difference. Yeah? So I hope this improvement will help you in sales. There is an example how simplified mode for such correction we have only one line. For advanced mode we have what you had in running 5. Okay, we can continue with the output report. on them now. So, in the report, there's now possibility to add pictures of 3D results into report. So you can add stress or strain check, and you can add equivalent stresses. Right? There were also complaints that not all data are really output report. This we improved that we have all information, which kind of analysis this data were there, but all these setup values are now in the program. I don't know which project it is, or run. So now document now gives much more information than before, like this. Listings, this is one page in detail. Here we have these pictures with strain check. If it's equivalent stress, you can set it in this setup dialog. So you can say I don't want these pictures. They should not be there. So this is required improvement. For foundation blocks, there are such tables here now. So about version 5, we do not have length of anchors and type of anchors. All the data is here. And what we also had as useful feature is that there is this theoretical background chapter. You can switch it on. And now you have in your document chapter about explanation of some important things regarding to CDPER method. It was required with several users. They made their project and then send it to some checker or investor, and they say, I don't understand really good. So now everybody can add directly this into the output report, and things can be much easier and much clearer. Okay, now you can go to verbs. For instance, here on this example, in each property dialog, we had section about verbs. It is still there, but we have a new tool for defining a verb. Here you can define the sequence of the verb. Here you can define material, and here we have tools for defining of verb type. And these thread verbs, thread verb, verb, and this is quite interesting. You can say that there is no verb, that there is no connection on this part, and so you can disconnect the plate, and you can use some different kind of connection. It's very useful for using of it. Like you can show it on, for example. On the track. You can see we have verbs. I hope you can see. Yeah, we have verbs on flanges, on that, and here either you can directly change the different or set different thickness of verb, or for instance you can say that is not valid. So with this tool we have the system is much more flexible in value. So we have these 4 types. No verb is very useful. What else? Let's calculate it. We have this simplified method. We have connected. We have supported on both sides. In the moment, of course. And if we go now to the verbs table, we have here the table with all verbs in the join. When you click on the line here, you can see on the plate where the verb is. You can see the plate where the verb. But what is new is that there are diagrams with internal forces which are in the web, and there are 3 pictures of intensity. In which direction it's going? This direction, so these 3 diagrams, and here you can see the final stress after the averaging, So this is directly this value which is here, also here, and this depends on what you define in the settings. Yeah, in settings, the settings are also a little bit modified. For well stress evaluation, we have average stress. Stress, it means that the stress is constant on the whole length of the well. You can use this evaluation of maximal stress. With this calculated value, which is without any modification, is almost calculated, and you can see it is more than at 16 previous, now it is 17, and there is now a third option, which is called linear incorporation. Yeah, it is calculated different way. It is symmetrical, so it is the same as before, but on different examples it can give different results. So we can now go to manufacturing operation, and as I told you, and the main improvement is that we can work with tubes or circular sections and try to find some projects. It's not good one. And here, and it is a typical example of welded tubes. You see that this operation is done. Maybe I can delete them and make them again. So this is now what we have without any operation, and we can say no. This is the same cut as before, so I will click on cut, and we say there is the and 4 cut it by for that. Okay. Okay, I input it from the scratch, it was an old project. So this one. There we go to design. See this cut. Can copy it. 72. Also cut. We go to geometry. One. Again copy. So we have now all these tubes are cut by this one, and now we have to make intersection between the vertical and the diagonal. So then we can say copy and say one cut it by V. Yeah. And this one we go. So these cuts we have. We can do also base plates for tubes. Like this is rectangular base plate with different shapes or this typical one. And this is the default solution we go to design. Here the shape of this plate is circular base plate, maybe 100. Also bolts can be now in this radial coordinate system. So the length of bolt is maybe number. The radius is 75. Yes. And TF8. Yeah. So this we have, and for instance we can add ribs. Insert default that can be 150. This is 5. Yeah, going there. Okay. We put it on 160 and remember. Yeah, so we have this tariff, but we have to start not in zero, but in the half position, which is okay. So this is improvement. The same we can do for this tubes, splice connection of two tubes, with only with end plates or also with relays. There is something new with this connection of hollow sections on cassette plate. In version 5 we can have one plate on the column, one plate on the connecting member. Now can be double, so this is quite often for if there is a huge force and the connection should be symmetrical, so this can support now quite easily. Prepare it yeah, here is this example. Here you can see there are two plates welded to the wheel, and in this example we have two plates welded to the column and one plate between them. So this you can change in property dialog. Like here, there is new plate twice, existing number, so it is one plate or two plates, and the same can be changed here. Again, more options, you can combine them. So this is quite new. Then I already spoke about this openings and notches. This is quite nice feature that that opening can go out from the plate. So for instance, this connection were required by some our clients. Yeah, it is connection of two beams of different height. And normally they are or thin plate or cleat, but sometimes they want to weld it, and you can see that that we can do it now. These operations, the first is that we make cut of this web with the web of the beam. Or it was a cut of length, this is the cut of web, so these two are cut it and directly welded then this tool. Then we have cut of this verb, but with offset, so the upper flange is shortened, and now there is the opening. Yeah. You can see this is a rectangular opening, and it is put in this position, and it goes out from the web. So in fact we made a notch, and there is the rounding. So it is really what we want. So it is about opening and notching. You can see also such kinds. This is again like notch, this is cut it, and you can use this creep connection here. This is sometimes they use it mostly on bridges for bridge connections. Now in properties you can define these openings. This is quite nice option. We have column of inclination in design. You can say that the orientation of base plate is either perpendicular, what is now, or it is horizontal. Yeah, so it can be like that, or it is vertical. This is connection to the wall. Now again you can see dimension lines, and you can also see that there is the bar in this dimension. This is not correct. It should be checked. It should be corrected. Yeah, but this was not. It was not possible to implement such connection in files. General cross section. You can see that we can use this kinds of connection, kinds of cross section, and this can be input in our IDEA ESS program, the cross section. But now we can use them directly in IDEA Connection. Yeah, so maybe developer is here, he knows this issue about this cross columns. We had one client made it in a tricky way. Now it can be done very properly as one cross section. Again, I can show how to make it. Which one we can use? So we are We are here in geometry. We can say in this valid component section, the last one, the general cross section. And now we are in the program general cross section or general cross section editor, and we can input one. And can add this. I don't know if you know this program. We can now. I want to put this angle to this position. So I say that this for this element the master component is this third one, and the master point will be this one, is number one. So this, and maybe we can insert it to point 8. Yeah? And I have it here. And now I can say copy. And I put it on the point 3. Maybe the rotation degrees, and instead of 8, 4. Yeah? So these options we have in general section. Okay. And here. Yeah, so this is one hand, so let's say one is yeah, and if I make cut, for instance, it's cut it like all other cross section. Yeah. So this the general cross section we have. And now stiffness of corrections. Here we made quite remarkable change. We added this stiffness analysis already in version 5, but we then realized that the results for more complex joints are not very good. So we change the calculation of this stiffness, and the main change is that when we analyze the stiffness of connection of one member, we do the analysis model that will support all other members. This is very important for proper analysis of this stiffness. And therefore we introduce it, and we are having here perspective in this one. Yeah. So when you want to analyze standard joining standard way, and the analysis type is stress strain. If you want to analyze thickness, you change it to change it here. Yeah? So you can say it is now for stiffness analysis. The difference is that you have to define number which you want to analyze in these settings in geometry. For instance, if I want to do it only for this B1, I say B1 and say analyze number, and then all others are supported, and only this one is not supported. And this one is calculated. Okay. So it is like that. Then in load effects, there is only one option to input load, so on this analyzed number. So here some comment. The design it's not modified. You can do everything what you want, but in check, in calculate. You see that there are only summary results, but they are only for telling you if it is correct or not. But from the result, we have only one table for this. Yes, you can see the calculated stiffness and its classification. So this connection is rigid. So this is real change in comparison with version 5, but now we think that the proper solution. In version 5 it was not really, in some cases it was not satisfactory. Okay, so we are at the end of the presentation. Only final information. You know that we can sell IDEA Connection in two editions. The basic one is called Expert, and there is a special one called Enhanced. And in this enhanced version, we have this analysis of the connection of member to the joint, and this thickness analysis is in enhanced version. The buckling analysis is in enhanced version. In general cross sections are in enhanced version, and in these general cuts or intersections of circular hollow section. Yeah, so these things are in enhanced version. This is the difference against this expert. So it's everything about news in release 6. I showed you everything. This document we sent to you, and I also made recording of this session. You can use this recording. And, I have to apologize for my voice today. I was a little bit ill in recent days, and it's difficult for me to speak. So I apologize. Maybe not perfect presentation, but I hope that the software is. Do you have any questions?
I have one question. Can I?
Yes.
Could you just one more time shortly explain about this red rectangle above the members?
Rectangle above members. It's a good question. You mean this one?
Yes.
Yeah. You know that when we start with this version with this CDFM method, there are a lot of questions where it is supported. Yeah, it is statical analysis, but where every structural engineer asked where is my support. Yeah, so we said no, it must be in equilibrium. Supports are not needed, so we will not show supports. But finally, we show the support, and this rectangle it should say. I'm not sure if it say, but it should say that our model is supported in or the end section of the member is supported for this stiffness analysis. We see that everything is supported. This end is free and can be loaded. And if I change it from stiffness analysis to stress strain analysis, so
In some cases, you can see the two arrows on this rectangle.
You mean this one?
No, I was thinking about the arrows on the same surface of this red rectangle. I saw two arrows, perpendicular arrows.
I think it was the shear force.
Okay.
If you mean this?
Yes. Here.
Yeah. We show all forces which are input in the table. Yeah. And it was done also in version 6 that all of them were showed, and in the place of support they were red. Yeah. But we show them, we still show them, because if you want to make equilibrium, you have to input all of them. Yeah, but they are red, and you see this rectangle, so it means that go directly to the support.
So this is like reactions?
It is force which goes directly to the support.
Okay.
Thank you. If it is in equilibrium, then it is like reaction.
Okay, thank you.
Lubos, one question about this support. So does it mean that all the plates that are there are connected rigidly?
Which?
Yeah, here for example. So you have the rigid support
here
below.
And here.
Does it mean that yeah, and on the top? Does it mean that all the suppose I model this in a finite element program, I would have to put the supports on the edge of the flanges and also on the edge of the web. Does it mean that there are all fixed supports there, or
Yes.
because that's a question I get a lot.
Yes, it's fully supported. In fact, we support the section of member. Yeah.
Okay. And go ahead.
Yeah. Another question?
Yes, I have another question about the enhanced version. And you say that the stiffness, the calculation of the stiffness is in the enhanced version, but in the basic expert version, it's also possible to calculate some stiffness there or not?
Not. We can discuss it, of course, with you. We discuss it with people here in our country. Yeah, you can see now this the result of this this support here. Of course, it is now it is supported here and here. As I said, if you are interested only in belts here, it's pretty good model. If you want to have influence of internal force, normal force and bending moment in the column, you should not use this simplified model. You say I'm interested in equilibrium, and you can put here. No. You can put here internal force and then you analyze the whole joint properly. So it is up to user and so. But your question was sorry.
On the stiffness, because I thought in version 5 it was possible in the basic version that they could calculate the stiffness and they didn't need the enhanced. But maybe I'm wrong.
We made this change, and there were two options: either to let this simplified method in expert and another method in enhanced, or to make only one method in the program, which is now this enhanced version, and we think that it's better to do it.
Yeah, I agree.
Now a little bit. For some clients it could be difficult. We should explain, and then maybe we get some offer special. But I think it's good to do it as soon as possible. This problem will be more and more difficult. But yeah, so we want to have this thickness only in enhanced version.
Yeah, I think it's good. Perfect.
Okay, another question.
I have one more. And if you are thinking about IDEA 6, do you consider only IDEA connections or also some improvements in concrete and pre-stressing?
This is whole IDEA Statica version 6.
Okay, so when we can see the concrete and pre-stressing improvements?
We plan to do it the same or similar seminar about concrete and pre-stressing. It's prepared by Yarda, and we will inform you. I hope it will be next week.
Okay. Thank you.
Luboš?
Yes.
Excuse me, I'm already
Can I
here.
ask a question?
Hello, everybody. Sorry, Emil. I just wanted to respond. I came because of a subsequent additional meeting which we have after this meeting. But I heard the question, so my answer is that I would plan it next Friday. Emil already asked me if we can do it, and we agreed to have it next Friday. So if you are free, you can do it either in the morning or in the afternoon.
Okay.
I will send you an invitation.
Okay.
So is it better in the morning or in the afternoon? Or same
on
time
Friday
as today?
Okay, both. could be same time.
Okay, thank you.
Thank you.
Okay, perfect. Emil had the questions already twice.
Yeah, not the same time. It was in the morning. Okay. So Friday morning at 11 next week. That's what we agreed on, or didn't we?
Well, you didn't answer. I answered that
sorry.
it would be better earlier or later. So and then then you left Skype. So there is a question unanswered, and that's why I wanted to end this. So if it's possible to have it 2 o'clock in the afternoon, as it was today, it would be the best for me.
But okay, but I cannot. I have a demo later the afternoon, so I cannot attend then.
Can you attend at 10 o'clock, for example?
Yes, no problem.
Okay, I will do it at 10 o'clock. If anybody else, everybody else can join it, and yes.
Okay, but I have a question about this moment rotation diagrams, Luboš. We sold it in expert enhanced, sorry. And where is it now? Maybe you already explained, but I left the meeting for several minutes.
It is. It will be in this enhanced version, but it is not yet finished because
so 6.1.
Yeah, something like that. Because we realized that it should not be this rotational diagram, but we need something like overall capacity diagram, or diagram of overall capacity of the joint. So we are not sure what is the best for the client. So we still think about it, and the idea is that here in this type of analysis, there will be strain, stiffness, and the third one will be this overall capacity, and this will produce this diagram.
Okay, and another question was, you demonstrated the new pictures from the equivalent stress. Is there the bolt force also there, and can I have different views on the stress, or is it just a fixed picture?
Now it is fixed view. I know what you want to have, but it's the better if there should be everything, or functionality, or if it should be simple. Now we still want to keep it as simple as possible. So yeah, we are able to make the output report like in global and RCL, but it does not.
No. That's not what I meant. The car user says we need more pictures of this equivalent stress, and if we give a picture that is not showing each angle of the joint somehow, it's not what I like. It is what the customer wants.
I think that finally we have to go in this direction, and we think that we should have in the software something like gallery of pictures, so you can snap the picture from the screen, and if it's into the gallery, in the gallery you can make you can rotate with the view and set what you want to see on this picture. So in the gallery we can be able to prepare pictures, and then pictures will be put into the report.
Okay.
Especially especially we think about this dimension, how to make pictures, proper pictures with dimensions. If you have any ideas how to do it, please come and come with these ideas and advice, because I think it is one point which we still do not know how to make it. But in version 7 we definitely will do it.
And what the anchor in calculation? That's still for people. It is still. It's often not okay. Did you do some improvements there? Sorry, maybe I missed it.
You mean that the check is not satisfactory?
ETAG calculation.
There is the issue with this breakout cone, that this special check which very often does not pass, and only solution now is that you can say in the setup that you are sometimes.
Yeah, it's already in version 5.
So already in version 5 you can switch.
At the bottom, I know.
Cone, you can switch it on or off. If there is reinforcement in this foundation block, in fact it's better not to make this check and do it differently. But we try to find some better solution with Yarda and concrete guys, but it is still not, it is not yet invented.
And I saw in my version that on the welds that there was a stress of a peak stress of 1,000 or 1,500 megapascals, and then we make it an equivalent stress, or we average it. Is it a correct model? Should it be there that you have such big stresses, although it is a peak? And the other question from customers is how can I see which forces from one component goes to the other component?
Which forces from one component? Everything from one
which
component.
force goes to the weld, for instance? You have one weld and it connects two plates, simple strip. You should be able to see that the total force of tension force goes into the weld and then goes out of the weld. Something like that. It's a component based.
We have this now this forces along the whole weld, so this can help a lot. But so in fact you propose to have not only this diagram of forces, but also some resultant value.
That's what people ask. Well, how can I see which? How can I verify my hand calculation on the weld of a plate or the plate itself?
This can be now evaluate very well with this new interpolation, this third option for evaluation of results. It gives the same results as if you calculate it by hand.
Okay, then I have to look at the document. Yeah.
Okay, if you have more questions, send them by mail and we will be better and we will get it very soon. Okay. We plan to have
maybe one final question, Lubos. Can we?
Okay.
Sorry. Can we test release 6 already? Is there a version already available for us dealers?
It's not on the web, but we plan to put it on the web next week. I think on Monday we will have some version for you.
Okay, perfect.
We put it on FTP only, not on the website, but you can download from FTP.
Okay, thank you.
Thank you very much for your participation. There's really nice group of people here.
It was really impressive, Lubos.
I agree.
To be, if you want to know my personal feeling or personal evaluation, I think that now the version 6 is the program, the real program. In version 5 we do still a lot of development during the time, but now I think we have all things required from all basic or main things required from people, and this is now it is real software. I'm quite satisfied with it. Okay, so now you can sell everywhere, every day. So thank you very much. We will keep you informed. Bye. Have a nice weekend.
Thank you. Bye.
Jan, shall we continue here? Also, you're right.
Yes, I'm here. Hello, everybody.
Hi, so I hope that Jan start
Jan is
to
muted.
speak. now it is, you're right, now it is your turn. I'm really, I have troubles to speak. I was
Exhausted after a fantastic presentation.
Sorry?
Exhausted after perfect presentation.